Well, welcome to this new video. This is about the Interlock system. This is a model railway signal box interlocking system. What a mouthful. So what is this about? Now, I have to confess, on my layout at the moment, there are no signals. However, after building this system, I'm going to add some signals because this has added a whole new aspect to model railwaying for me. Now, I was asked to sort of look into a particular project to have an interlocking system for a model railway, but rather than building a system just for one specific layout, I decided I would build something that could be used on any track plan. So let's get into interlocking. In front of us, we have the picture of a signal box. Now, when you think of the signal box, we can change the various signals. We can move the turnout or points, depending which nation you're from, just by pulling these levers. At least that's what seems to happen. However, behind the scenes, there is a whole safety system that is sort of behind the scenes that stops signalmen doing something stupid. Now, if a signalman does something stupid, if he makes a mistake on a railway, it will usually end up in catastrophe and deaths, and this is why interlocking was designed. So let's think about signal 2 here. For signal 2 to go green so that the train can move in this direction, there are certain things that have to be in place. Firstly, obviously, the turnout needs to be in the direction for, in this case, 0. Also, signal 1 needs to be set at danger, at red, because the turnout is not pointing in this direction. So if a train was to pull off here, firstly, it will come off the track. Secondly, it could hit the train going in this direction. We also have to make sure that these two signals here are set at red so that nothing can attempt to come in the other direction. So the interlock means that before this signal can be set to green, these items have to be in the correct position for that to happen. Now, in the olden days, when they built manual signal boxes, what they actually did was they had a series of levers and rods that went across in different directions. And I want you to think of these almost like a lock on a door, where this is the key that goes in. But depending on these different lines going in opposite directions, the lock is actually changing shape. So the lock has to be in exactly the right shape for the key to be able to move in and out. Now, what that means is that before maybe this turnout can be pulled, certain signals have got to be in the right position to make the lock work. Now, as time went by, some of these old signal boxes were replaced, and they were replaced by these panel boxes. Now, these panel boxes were often very, very remote from the track location. Some of them could be 20-30 miles away. So they covered a much larger area, and instead of moving mechanical levers to switch turnouts, points, crossings, signals, they had buttons and switches to do it. However, behind the scenes, they finished up with a whole load of relays that replaced the old mechanical system, but were working in an electrical method that sort of simulated that mechanical lever frame. Now, moving forward to the modern era, obviously they tend to use computers, and I would imagine some of these are touchscreen systems. So the operator can now just touch the screen to set a route for a train. However, even with a system like this, there has to be a set of interlock rules that prevent the operator from doing something that would lead to a dangerous situation on the track. Now, looking at this pretty simple diagram, we've got a through track, we've got a track that comes through and continues off. siding and siding. I've got some various signals for it. I really became impressed with signaling engineering because even in a small system like this, I finished up with 89 rules, and that was just for the turnouts or points and the signals. Now, if you add in what they call blocks as well, so a block would be where the system recognizes that a train is on a piece of track. So of course, it's not just a case of setting a signal, but saying like the track is set in the right direction, but it's also saying the track might be set in the right direction, but there is a train sat on that track, so you cannot set this signal to green. So I've set 89 rules just with the turnouts and signals. So I must admit, I've got a great admiration now for Signalbox engineers, whoever those people are. Now, much as it would be great to do a demo on a track plan like this, unfortunately my breadboard is not that big. So this is the track plan I'm going to be using. It's just this very, very simple plan: a single turnout, a signal from this siding, signal on the main, and then a signal to turn right into this siding and a signal to go straight ahead. Now you'll notice I'm using red and green as the signals. To be honest, on some railways, if you're a signaling expert, you'll know this may not be a green to go in here. Sometimes it will be what they call a feather signal in the UK, where there is a sort of, this signal will go green with a string of white lights, or it could be that this signal goes amber with a string of white lights. In the interlock system, it doesn't really matter. You decide what happens with the output, but these are the, if you like, the colors that I have chosen for my plan. Now, one thing on the breadboard, for the turn right signal, to simulate a feather signal, I've just made this a blue LED instead. So going over to the breadboard, this is my system. We have two signals at one end. This has the blue LED that is to turn right into the siding, which is also has that signal 1, 2, the turnout 4, 3 and 5 are the signals. These obviously are the buttons that are going to control it. Those, if you like, are independent of the interlock system. The interlock system doesn't care how many buttons or servos or LEDs you add. The system, I think I worked it out, it'll take 60-odd thousand, which is big enough for most layouts. Now, the components that you need, you will need an Arduino Mega. I'm doing some work to see if I can get this to run on the ESP32. Just got to make some mods to the screen code for that. It needs to be on a Mega, not an Uno. The reason is the sketch itself is small enough for an Uno, but it uses too much SRAM for the variables due to the arrays that are needed. So the Mega has more SRAM, hence the need for a Mega or another larger board. The only other items, there is one button. This is to switch the mode. So there is training mode and there is full interlock. Now in training mode, if I switch any item, it will move, but if there is an interlock error, I will get a warning. If I move over to full interlock mode, if I try to do something wrong, the item will not move, the signal won't change, the turnout won't switch, I will just get an error. So the reason for having the two modes, if you're enforced full interlock on a layout and you just needed to quickly move something around the layout, you really don't want to start setting all the signals, it could become a real pain that you've got to go into full interlock mode. So by having the trainee mode, you can just move the locos as you wish. It is a model railway after all. Right, the other bit we have here is a beeper, just so that you get an audible warning that you have made a mistake. And obviously in a club situation, this lets everybody else know that you made a mistake as well. So I'm now trying to superimpose the video over the track plan. let's just switch to training mode. So training mode, let's set signal 5 to green. And now I want to move the turnout or the point. If I press 4, it moves because it's in training mode, but what it says is point 4 when it moved to direction 1. So on my track plan, this is direction 1. There is an issue, an interlock error with signal 5, which is set to 1, which means it is green. So that is my interlock error. If I now turn the signal off, and now I try to move the turnout, as you can see, I no longer get an error. Obviously, it's still got the old error message on there, but you can see that I'm not getting a new error because as I move the turnout, it is guarded by red signals. As soon as I set a signal to green, if I now try to move, once again, I get the error. This time it's telling me that signal 2 is the interlock error. Let's just turn that back to the correct direction. Again, it's beeped even when I move it back because I should not be moving this turnout if the signals in any direction are green. Now the next thing, let's imagine we now set signal 5 to green. If I do that, now I get an interlock error. I've sent an instruction to signal 5 to go to a value of 1, which is green, and it's saying the error is that signal 2 is opposing it, and that also has a value of 1. Now, if I set all of my signals back to red, so everything is fine, what I'm going to do now is change the interlock mode, and now we're at full interlock. So now, guarded by red signals, I can change the turnout or the point. But if I now set a signal to green, now when I try to move the turnout, all I get is the beep, the alarm to say you did something wrong, and it says what I've done wrong, but you'll notice the servo didn't move because it didn't pass on the instruction to the servo for safety reasons. Now in the Signalbox, I wouldn't have been able to move that turnout because the interlocking frame would have stopped me moving it. So that's basically how the interlock system works. I'm able to put a set of rules into the sketch, and the interlock system, every time I press any item that is going to send a command to a signal, turnout, whatever, it will check through all the rules first to say, has a rule been broken? And if it has, it's going to warn me, and in trainee mode, it will allow the item to move. In full signaling mode, full interlock mode, it won't allow the signal or turnout to move. So let's take a look at how the system is built and how it works. If you go to the link below the video on the Interlock page on the Digital Town website, you will come to the resource page. So once we get down to the resource page, we have an introduction about interlocking. There is a link here to a Wikipedia page on interlocking so you can read more information. There is some information and the circuit diagram. The circuit diagram is very easy. This is the 1602 I2C backpack version. Sometimes when you buy an Arduino starter kit, you get the one with all the connections on the top. I forget how many connections it actually is, but the version I'm using only has 4 connections just to use less pins on the board. You then require a button for the mode change and that little piezo speaker just to give the dreaded beep. Moving down, I've then got the larger track plan, and I've got an explanation of how I set up that particular sketch with all the rules. Then going down further, there is the code. The version at the moment is 0.1 because I still call it a beta version, although I've tested it as much as possible, but it needs a little bit more real-time testing, so any feedback would be appreciated. Just stick some comments below the video or email me on the link at the bottom of the page. Below that, there is also a load of additional resources on using different components for model railway control, which can all be used with the interlock system. So take a look at whatever sort of switches, latching switches, servos, MOSFETs, solenoids, whichever you want. There's a whole load of information here to help you with any questions. Right, let's have a look at how the code works. So coming over to the sketch, we start off with the wire library. This is required for the I2C screen, which is using the liquid crystal _ I2C library. I then set up the screen on its default address of a hex value of 27. And then we get into the Interlock system. Now, in the example sketch, I have put 5 types of inputs. I've got type 0, which is other. Other is the one that I can't think about, but you might know what it is. I'm doing an English version, so I'm using the word point, whereas in the USA and other countries, you might use turnout. That has its own value. Signal, it has to be T signal. You cannot use the word signal on its own because that is already used within the IDE system for something else. So I just added a T in front of it. I've then got a block and also a crossing. Now, if you want to add more types, if you can think of something else that you want to put in, you just put another line in, define the next item with a value of 5 and update the num input types to 6 if you've added another item. Moving down the sketch, we then have some strings in an array, and these refer to these input types. So if you don't want to use the word point, then you can change that to turnout. And obviously, if you add another type, you're going to need another element in the array. So these words here, these are just for the messages that come onto the screen. And by having them just in this small array, it saves having endless text messages and also reduces the amount of memory that the system requires. So once you've got your input type sorted, and to be honest, for most people, these will be left as they are, apart from those on the other side of the water who are going to change that to turnout, and again, that line there. Once you've done that, the next thing that you do is you put in your number of inputs. Now, the inputs refer to all the different items that are going to be tested in the interlock system. So for me, I have got signals 1 to 8, and I have got points 9 to 11. Turnouts, again, for those others who use that word. Right, some bits that you need to know. These numbers in this column here, the first column, must be unique. So on your track plan, you need to make sure that everything is a unique number. So I numbered all my signals first, and then I added in my turnouts. Now, it doesn't matter which order these are in. You put them in any order you want. So if you're working on a diagram, you might want to start from left to right, right to left, top to bottom. It's up to you. But all you need to know is that you cannot have signal 9 and turnout 9. Each item must have a unique ID number. Now, coming back to the sketch, one other thing, the unique ID number, they do not need to be sequential. You can put, if you want your points, your turnouts to be a different range of numbers, no problem at all. But it is these values that will be used to compare one rule against another. Then you put in your item type. That comes from our different types of inputs. So I've got signals and points in my setup. The final line has a row of zeros. You don't need to worry, just leave a 0 in there. That is the default value, and this value gets changed by the system as it runs. Once you have your list of items, then we come down to your commands. Now, you can just send a 0 or 1, but I've created some definitions just to make it easier for me to read. So signal stop is a 0, signal go is a 1. On my track plans, I use point left and point right. So if we go to my track plan, a 0 for me is turning left, looking from the end of the turnout. Right is a 1. On your system, adjust that to however you want to define it. The system doesn't care. If you were to swap those values over, it really doesn't matter. The system will still work it out for you. What is important, though, is that you understand with turnouts or points what those values mean. Now, obviously, for the USA version, I've just put the alternative turnout left, turnout right. I know sometimes they use a different system, but that's up to you. If you're using blocks, so you may be using sensors for block occupancy, or you may be doing a full signal box with tokens or block signals, then again, the system can take a block value. I've also put in a couple of values if I wanted to have a crossing. Actually, that's a spelling mistake there. Let's just sort that. And then I've got other stop and other go. Now, once again, these are all related to your input type. So just make sure that you've got one for each input type, but you can just use the 0 or 1 instead if you wish. So now we come down to the rules. Now for this simple track plan that I had, I finished up with 83 rules. So what we have is for turnout number 9. Let's just see if I can get all of this on one screen. So here is turnout number 9, and that requires signal before this can be moved, and this applies whether it's moving left or right. But if I'm moving to position 0, this signal must be at danger, this signal must be at danger, and also these signals must be at danger. So those are the rules that must apply before I can move that turnout. If I want to move it in the other direction, you can see I've got a similar set of rules, because a turnout or a point should not be moved under a green signal, because if a train approaches the turnout halfway through the move, it's going to be a pretty disastrous day. So I wrote all the rules for my turnouts to be moved, and then I started with the signal system. Now if we look at this, it's quite simple. So it's turnout number 9, ID 9, for it to move, item with an ID 1, which in my case is a signal, must be stopped. 2 must be stopped, and then those other two signals, 5 and 6, must be stopped. 7 doesn't necessarily have to be stopped, because T11 could be position 0, so a train could happily sort of run down there, and that doesn't affect that turnout. Again, this gets quite interesting working out the rules for your layout, because if this turnout is right on the toe of this turnout, then you may need to prevent trains from going down this route as well. Depends on your track plan how the rules work. So scrolling down now to the signals, I'm just going to do signal 2. So signal 2, for this to go green, signal go, turnout 9 must be left, which for me is 0. Turnout 11 must be right, which is a 1. Signal 1 here must be red, because obviously you can't have this signal being green and this signal being green. And also signals 5, 6, and 7 must all be at red, because no train can be coming down here whatever direction it's going, because the track is set in this direction and we have a train going this way. So this is the way that you enter your rules into the system. I can tell you, you will make plenty of mistakes when you first start. It really did give me an admiration for the guys who designed interlocking signal boxes, but you just continue working down until you have entered all of your rules. So once the rest of the rules are done, there is just some variables in here. There is a FIFO buffer within the system. So what happens is instructions get put into the buffer as different signals come in, so different buttons are pressed. The reason for the buffer is that it is possible for one button to send more than one item, more than one command to the system. So the buffer works through the sets of rules one item at a time. The timer is currently set to 1 second. I've got it set very, very slow on my desktop. I think I've got this set down to 100 so that it reacts far faster. The reason this is set slow, you will see in a moment. I've got a buzzer pin at 2 and the mode pin at 3, and the default mode state for mine is 0. 0 is learning mode, 1 is interlock mode. I've then got a debounce set of timers for my mode button, and then I've just got a variable string which holds various strings through the system and is changed constantly. Serial monitor gets started up and information does go to the serial monitor. We then have the LCD screen started up. When the system starts, it will set the pin mode for the buzzer, and it will do a quick error tone just to show you that the system is working. And then the LCD screen will display the interlock information before getting itself blank, ready to start the system. Then it's going to display the current mode that the system is set, whether it is in training mode or full interlock mode. Now, because this is a test sketch and it doesn't have any buttons or signals connected to it, I just wanted to test the rules. Now, the rules are triggered by this function. So all you do is you send, in this case, signal 3, I'm going to set to stop. And then you can use these, or you can use a 0 or 1 once you get used to it. So what I've done, signal 3 has been set to stop, signal 4, signal 7, and then signal 8 has been set to a 1. Now, the reason I picked these signals is if I'm setting signal 3 to red, signal 4 to red, signal 7 to red, so that's stopping a train coming down here, I have then set signal 8 to a value of 1, but the default direction for turnout 10 when the system started up was 0. So actually the track is set for this direction, which means that signal 8 must fail. So it must fail the interlock test. So when I run this sketch, the first items will run correctly, then I will get a beep for the 4th instruction that's sent through. And that's why I'd got the timer set at 1 second. So let's upload the sketch and see how it works. So I'm going to upload the code. Let's watch this one go. So it's uploading. Start. We hear the beep, test beep. Now we get an error. Now looking down the rules that I passed, we can see that setting signal 3 to a 0, no problem. 4 to a 0, no problem. 7 to a 0, no problem. But then because of the position of turnout 10, when I set signal 8 to green, that's when suddenly, where are we? We get the error, and that same error can be seen on the screen explaining that turnout 10 is in the wrong position. So as you can see, for testing purposes, you can just put a set of items in the setup and it's going to send those across as if they've been sent by a button or a sensor, and you can test your rules to make sure that the appropriate error messages appear. So outside of these instructions, the next thing just to look at is the main loop. Now the main loop only has these 3 items in it. The one is current millis, where we're taking the time in milliseconds since the board started. We have a check interlock FIFO call. This is basically the heartbeat of the system. So when we send an instruction to the system, it goes into a buffer. The reason it goes into a buffer is, as I've said before, multiple instructions could be sent from one button press. So the system then works through these different commands one at a time, checking them against their set of rules. And then we have another function, which is check buttons, which is basically a debounce coming down to the bottom of the sketch, which is doing a debounce on that mode state button. Now, the output from the check interlock FIFO system is, once it has checked to see if any rules are broken, it then has an output, and the output is where you now send your commands to the layout itself. So if you look at the interlock system, it basically, instead of having a button that sends a signal to the microprocessor that then sends the signal on to the servo or solenoid or whatever, with the interlock system, you send the signal to the processor, which then passes it through the interlock system, and if it passes, it then sends the command onto the layout. And so this is the set of commands. So if the item that I have sent across, let's say we want item 3 to do something, when the interlock has passed, it will then, you then put your processing code in here. At the moment, I've just got a set of serial prints just so that I can see that the results are correct. But for each item that you want to do something, you just need to put it into the switch statement. And again, you can have multiple items in each processing section if you want. So that's the theory of how the interlock system works. Let's now look at a practical demonstration. Now, for this one, the main difference at the beginning of the sketch is I've only got 5 inputs. I've got 3 signals, a point, and then another signal. Now, the reason these are out of order is I forgot I was going to need this extra signal. Now, the great thing about this system is you can just add another element in whenever you want, and then just change the number of inputs. Coming down then, we have the interlock rules. Now, again, because it's only a single turnout, there are far less rules, only 24. Incredible for such a small thing. And again, it gives you an appreciation of what signal system designers have to go through. Very clever job. Right, once we've finished with the variables that we've looked at before, one thing I did change, by the way, is the timer. Now I'm at a 100 milliseconds. Now coming down here, the buzzer still on pin 2, mode button pin 3. I've got my debounce timers, my string, and then we come down to the custom sketch edition. So these are the parts below this line where I have added stuff to the sketch. So the first thing I did was I've got the servo library, my servo, and I am running on servo pin. The servo pin is 7. And then I've got a set of buttons. I'm using pins 12 down to 8, and some of them are for signals, and pin 8 is for the point or the turnout. I'm also keeping the state of the buttons because it's a single button, therefore it's press once for one direction, press once for the opposite direction. That's because, to be honest, the breadboard was a bit tight on space, and I didn't have space for, if you like, one button for one direction, one button for the other direction. Coming down to the setup, again, everything stays exactly the same until we get to just after the servo. After the sort of the LCD screen, I then attach my servo. Now you'll notice that I did a servo right, a delay, and another servo right. I did that in the setup just to test that the servo worked, because there's no point sort of screaming and bawling at the code that it's not working later on if you suddenly realize that you haven't connected your servo correctly. Then I'm using a PCA 9685 board for the LEDs. So for that, I included the PWM, the Adafruit PWM servo driver, and I am using the servo driver on address 40. So it's the default address. So coming down to the main loop, I've started up the PCA 9685 code. I've set the frequency for 1600, which makes LEDs smoother, the lighting. And then the next thing I did was I went through a little routine from Q equals 0 to Q is smaller than 16, and I turned on all the LEDs, and then I turned off all the LEDs. And that was part of my testing, just to make sure that I'd got all my connections correct. Now, the next thing, this is the real deal. So unlike a test system, I need to have the LEDs in a default state. So my default state is I want the LED on. Now, there's two ways of doing that. I could send interlock instructions in this format, or what I finished up doing in the end was just going through the PCA 9685 board and sending instructions to pins 0 to 13 and 15, which are the pins that I've got the various signals red lights for the signals connected to. So that then starts the system with the red lights on. Coming down to the main loop, I've got that check interlock FIFO and the check buttons, as well as obviously as current millis. I've left those in as before, and I then added a couple of other variables, a myDbounce millis and a myDbounce timer. And this was just to keep the debounce for, if you like, my signal buttons on a slightly different system. So I have put the code in for that within the main loop, and all it's doing is checking if the button has been pressed. If a button has been pressed, it then looks at the current state of that button, whether it's set at 0 or 1. It flips the state, and then it sends the insert interlock instruction into the interlock system. That then works its way through the system. It either gets an accept or a reject as it works through the rules, and then the output once again comes to the update layout function. Now I have left the serial prints in here just to make it easier, and if you're wondering what this is because I just pasted it there so that I could remember which settings to put in to the different items. So there is a switch statement for the different items, and as you can see, I've got the item 1, which if I look on my signal diagram, that obviously is this signal over here. And what happens then is we're going to set pin 2 is going to be turned fully off. Pin 3 is going to be turned fully on. This is on the PCA 9685 board. Obviously, Pin 3 is going to be a green LED. Pin 2 is going to be the red. Obviously, if I go in the other direction, I do the opposite. So I then just worked through the different case statements for the switch. The main difference is when you come down to case 4, because case 4 on the track plan is the turnout, which I'm driving by a servo. So if it's a 1, it's going to set the position to position of 30, and if it's a 0, it's going to set the position for 90. That was just so that it looked nice on the breadboard. Obviously, when it's turning a real turnout motor, then those figures will be changed appropriately. But realistically, that is all there is to the system. So you have to have a system with your buttons where you send the instruction to the interlock system, and then in the update layout function, you just put in what you want to happen when these if you like, the command has been checked through the rules and is successful. So going back to the breadboard, I've put this in the full interlock mode, and I must admit it has been fascinating working out how the signaling system needs to work, and slowly processing through all of that. I've certainly learnt a lot about how signals work, that's for sure. So a very interesting system, and of course all the time if I make an error, it's going to display that error and give me the warning. So that's the interlock system, and if you're interested, just go over to the website, just download the code for free and play away with it. Now my goal going forwards is to add some ESP32 support and a few other bits and pieces. Obviously the code can be modified to work with DCC, EX and NCE cab bus. I know that's reasonably easy to do. I've got both of those systems, so I'll probably have a go at that. And I may even make an interface into the NowRail system. So if there's any bits that you would like to see added, please let me know. I'm going to rewrite the code a bit more into more of a product type thing, just to make it a little bit easier, and I'll probably put all the functions into a separate class. So there's plenty of bits to add, and if you're interested or you want to know more or you have any suggestions, please just let me know, and I can be contacted either in the comments below the video or off the Digital Town website. At the bottom of the page there's an email address to get in touch. So thanks for watching, and I hope the system makes signaling a little bit more interesting. It's certainly made it a lot more fun for me. Thanks for watching, and I'll see you in the next video. Bye for now.